we're going to prove the distance formula. Theorem. Given 2 points, given 2 points, x1, y1, and x2, y2, the distance between these 2 points is the square root of x1 minus x2 squared plus y1 minus y2 squared. And of course, so we know that, let me not use y, we know that z squared and negative z squared are equal. That is, I can take the negative of that and it would be x2 minus x1 squared plus y2 minus 1 squared. And of course that's going to have to be true because, for example, if I have 2 points and I don't know, this is AB and this is point CD and I want to find the distance. Well, do I do C minus A squared plus B minus B squared square root? Or, in other words, let's suppose we're using this formula. So that is, like this is 0.1 and this is 0.2. The distance between 0.1 and 0.2 has to be the same as the distance between 0.2 and 0.1. That is, I should also be able to say the distance is a minus c squared plus b minus b squared square root. And I can. And the reason is because when you square something and you square the negative of it, doesn't matter. 5 squared is negative 5 squared. They're both 25. The distance is never negative. If I asked you on Monday, or if somebody asked you on Monday, how far, so you're in school and somebody says, how far is it to your house? And you say, of course, how far from school is your house? And you say 5 miles. And tomorrow, you're at home and somebody asks you, how far is it to your school? You're not going to say negative 5 miles, okay? You're going to say 5 miles. That is, the distance from A to B, to make any kind of sense, must be the distance from B to A. It just has to be. Okay, so let us prove this. So we draw our xy coordinates. We put x1, y1, say, right here, and I don't know, y2, sorry, x2, y2 here. And the reason, there's only one reason that this point is x1, y1. And that is, when you look down to the x-axis, you're going to see x1. And when you look to the y-axis, you will see y1. And there's only one reason why this point, there's only one reason why this point here is x2, y2. And it's because when you look down, you see x2, and when you look across, you see y1. Okay, so let us find out what the distance is between those two points. The distance between that point and that point. Now, you can make a right triangle and use the Pythagorean theorem. You can go straight across and straight down. Now, what is this point? Get your hands dirty. Look down, you get the x value. Look across. Okay, so that didn't look like y2 to me. You look across and you see y2. So, Pythagorean theorem would say, well, is this the distance squared, called this d, the distance squared will be this distance squared plus that distance squared. But you have to remember, this distance is top minus bottom. It's y1 minus y2 squared. Plus, this distance is at the same height, so it's right minus left. The same as this distance is right minus left. x1 minus x2 squared. So, d, without the square, will be the square root of this. And just so it looks like what I got, it's this plus that. Addition commutes. x1 minus x2 plus squared plus y1 minus y2 squared square root. That is the distance form. I like to call this the change in x squared, and this being the change in y squared, square root. So, when somebody gives me 2 points, 3, 7, 4, 11, I ask myself, what's the change in x? It's from 3 to 4. It's 1. So 1 squared plus, what's the change in 1? You go from 7 to 11, what's the change? It's 4. Square root, this is 16, this is 1, the square root is 17. Don't have to subtract and all that stuff. If somebody gives me the point 2, 4 or 12, 4 and 3, 9. So the distance is the change in x squared plus the change in y squared square root. And it doesn't matter if you get a negative change or a positive change. When you square it, it's going to be the same. Well, the change in x, it went down 6. You want to call it negative 6? Fine. You can call it positive 6 if you want. The change in y, 4 to 9, went up 5. So, it's going to be 36 plus 25, the square root of that. And that sum looks like 61. So the distance is 61. We derived the distance formula. We even looked at a couple of examples.